complex piece of software. I mean, come on, guys. You guys have had your headaches writing a serializer.
Complex piece of software that's been around since as far as computers.
That doesn't make it easier.
And that was acquired by Microsoft. They bought this company. So the Word group and the PowerPoint group have nothing to do with each other. Even though the UIs look so similar, there's no common code base there. That's what I didn't know either when I went to Microsoft. I said, I'll go and make your Office collaborative. I already had done a project with OpenOffice, with an undergrad. And I said, we'll just go and make your Office collaborative. And then they said, are you kidding me? We can't change that code. We dare not touch it.
I guess that's why they came up with that.
Sorry?
I said, you're trying to make a collaborative office where the office guys don't even collaborate with each other.
Well, they can't. No. I mean, it's just that what is in California, PowerPoint was in California. And it was just a different company. And they could have had two choices. They could have made PowerPoint and Word not look like each other.
How did they make Office for Mac?
I don't know the whole story there, and and they always make sure the Mac Office is pretty watered down. At least I feel it's watered down. A lot of people say that's a feature. We don't have too many features there. That's good. But there's always behind, right? And they must have just re-implemented. It's not as maybe the PowerPoint company does it. Who knows? I don't know details. I wasn't interested in the Apple version. I was interested in the Microsoft version. I was interested in doing something. But that's what Google guys did then afterwards. They just said Google Docs. And what did Google Docs do? Google Docs don't have PowerPoint that's as powerful as PowerPoint. So right now the feeling in collaborative systems is you can either get the nice single user features or you can get the nice collaborative features. You can't get both of them. Unless you could go and re-implement Office.
Why does Excel seem to have excellent collaborative features?
It's a simple data structure. It's just a table. Look at how complicated this data structure is.
Yeah, because like Excel, you can have multiple people in there editing.
But it's so nice. You have these cells that demarcate things.
Yeah, it's true.
It's so easy to come up with a transaction. Like just the idea of a transaction is embedded in
There is no dynamic list array. What happened? The problem in Google Docs and Word is that there's this list, and when I insert a character at number 0, and you insert a character at number 5, my 5 has to become 6 to take into account the fact that you inserted at 0. In Excel, you don't have to worry about that. PowerPoint is easier. Okay, because again, if I add a slide, same issue. So anything that's dynamic is the issue.
But Excel is clearly marked. Each cell is.
You are appending or,
Collaborative Excel just boils down to a timing problem, like keeping track of everyone's different timings and making sure things resolve in a good way.
And Excel is often used for project reports. And that's nice. I go and enter my cell, and you enter your cell, and we just don't interfere with each other.
We did regression testing on the mobile app, and you would just save it, and it would be like, oh, I brought some changes in from so and so who happened to be editing it at the same time as you. So an Excel document on a shared drive, it would just drive everything.
Okay,
Great.
RMI, boring, So how does RMI really work? Okay, so we've done when I say RMI here, I mean remote method invocation, not Java's remote method invocation. Okay, we've seen Java's RMI, and now we're looking at we saw Java serialization. Then we said let's look at the issues in design and implementation of serialization. So we looked at it in a very broad way. We looked at Gypsy, looked at IDL, looked at C. Similar thing I'd like to do with.
One question: RMI and RPC can be used interchangeably?
I use them, but RPC is more general. So RPC is something that C also implements, or C could implement.
What are the general differences between the two?
So method means on object.
Yeah, a procedure is necessarily a method.
All right.
Okay, that's the way I would do it. Okay?
But a method is just a procedure with an added argument. This object.
Okay. So I mean, everything is a Turing machine. Yeah.
Except it's not. It's discrete.
It's not. It's a finite machine with a lot of states.
That's right. Okay. So what's the big deal about RPC? Okay, we saw way back that if we have remote assignment, we can go and simulate remote procedure call using remote assignment, right? So we send expressions encoding methods and parameters. Okay, so I go and send this. I assign these to some variables there, and then we go and invoke a method. Okay, so in principle, if I just want to go and hand wave and say, what's the big deal? Everything else is detail, implementation detail.
That's the hell. Is details.
Right. Of course, the devil is in the details. The research is in the details also. Right. So, side effect of assignment is to call the method. So but at least we should, so we're going to look at this whole idea at multiple levels of abstraction, and this is the highest level of abstraction. Okay? So I'm coming from a distributed computing point of view, and I'm saying I know message passing, and this is what remote RPC is. Let's say I don't know anything about distributed computing. I'm just a 101 programmer. How would I define RPC to somebody who knows LPC, local procedure call, who knows compilers also? I mean, from an implementation point of view, fine, the method is invoked on the other end. But when a method is invoked locally, how would you define it? How would you explain what steps happen?
Okay, I think I might actually see that. When you get to it's like doing procedures in assembly. You have to copy your parameters into certain registers, and then you have to do a to a certain label, which is your procedure, and then you got to read the parameters back out, and then you can do it, and then you jump back to where your program counters.
Okay, that's good.
So it's like at the I guess
at
the biggest level.
It's kind of I'm telling you, Rob, with GoTo and all that stuff, you are made for C.
I feel like that is like the worst thing anyone can say.
No. My progression through life is I was interested in physics, got interested in EE, got interested in digital electronics, got interested in architecture, did microprogramming, did assembly programming, and I'm doing user studies now. Right? So that is the way I understand things. I didn't go with lambda calculus and understand this all mathematically. Okay? I understood this all using that. So I have literally done microprogramming. I've taken switches and gone and programmed ROMs to go and make it all work. So this is, I have a lot of respect for anybody who can do that. Okay?
My 101 was in Java, so I'm going down.
Okay.
What do you mean, how would a 101 program? It's just that...
So it's not 101 program, a compiler guy. So he said GoTo, etc., but these registers, etc., are being copied. Where are the values being copied?
Well, so that's the thing. So when your compiler is going through your code, it comes up with these names, with these bindings.
Right.
Like at runtime,
And at runtime, what does happen? What happens? He explained that at one level abstraction. Can you do it more concisely without GoTos, with using a better data structure than he talked about? What data structure are we talking about when we're doing all these GoTos?
One stack.
Stack. Okay, so what am I doing? When I make a method call, in terms of stack, what am I doing?
Pushing.
A what?
You're pushing a procedure call.
An activation record.
Yeah.
An activation record. It's an activation. That's the.
It's like a little bit of stack memory and like your.
There's a record. There's some frame, right?
That this method was invoked.
A representation of the method call, because that when the method dies, you're going to pop the stack.
You're going to pop the stack, and with that basically blocks the stack until the method returns. Right?
So the method call is translated into data structure, which is popped in the stack, pushed on the stack.
But you push on someone else's stack instead of your own.
That is RPC. Okay.
Okay, stop.
Okay.
I don't think that's the way it works.
Okay. Do you want to say I don't understand that way, or do you want to say that I understand that way completely, but it doesn't work that way?
No, if an RMI, right, the whole point of that activation record is to block your own stack until, of course, that method returns, right? So when I'm doing RMI, I have a stub to open object, and I call the method, and I have to block myself until that method returns.
Right.
So that activation record will not be pushed on my stack, but will rather be pushed on the stack, whatever thread is receiving the remote.
What did Derek say?
Me?
No, Derek said that.
That's what I said. That a remote procedure call is you're pushing this activation record onto someone else's stack.
No, but I should be the one blocking, right?
But you can, because you can, well, why not push a little one onto yours that says wait until I get.
There's still something that's got to be pushed on yours.
Well, of
So,
course,
like,
of
yeah,
course.
yeah.
But we're saying,
I'm
like,
not-
the remote part of the remote procedure call is essentially you pushing this down on someone else's stack.
And the waiting part, that we are just saying is the one that you're going to spend your next 2 weeks doing.
Oh.
Yeah, that little record that gets pushed on your own stack.
All that I'll do. You guys just do the waiting part. Okay, so it's and it's not that hard, but I'm just saying. So calling process, we have a stack which contains parameter, return value, return address, and other information. Okay, you make a call, you push on the stack, and now what's happening is that activation record is serialized into, marshaled into a message.
Difference between serialization and marshalling
Is, what did I just say?
I wrote it down. Serialization. Marshalling is serializing a method call into a message.
It's a special kind of serialization. Okay? Which should all work magically if your serialization works correctly. Okay. Or there's some other issue. Okay, so we send this message across, and so then we get an activation record here, right? And that activation record gets popped, a message gets sent back.
So what was that thing on top of the activation?
It was you're waiting on the return message.
Okay? If you're doing waiting. If you're not doing waiting, you can just pop that thing off immediately. So that's...
Then what happens to the return?
Well, if you're not waiting, you've got something that's sitting in another thread somewhere that as soon as it gets a notification that there's a message.
Something like a
Major
feature?
or something.
No, like a selector thread.
And then
Yeah, anyway, these are all questions that will be answered for you when you implement things. So I'm glad you have these questions because, the assignments are going to answer your curiosity. They're going to help you basically explore your curiosity. So,
Thank you for helping.
absolutely, that's my goal. I mean, come on, guys. If I'm not trying to help you, what am I doing? I mean, really?
Yeah.
Okay. So unmarshalling of call, translation of call, and so marshalling of call is translation of call between call and message, and unmarshalling is the other way around. Okay. So I'm just saying in text. So you're basically sending a message rather than pushing on the act. So let's go and see it at another level of abstraction now. Okay, so for this to all happen, we are assuming that there is some data communication channel established. Okay, let's not start from scratch. Which means server exports some external description of some data port, statically or dynamically. Okay, and the client goes in and makes it port connectable, and the client goes in, somehow knows the external description and connects to it. Okay, that stuff is taken care of by the remote assignment layer. Now, what other thing do we need in data setup, not the per call processing, but the setup processing? What else do we need in RPC?
We need a naming scheme
For
where we're wanting the call to actually end up.
So we need to go and say, these are the objects or these are the methods that can be called remotely. And maybe these are the names that can be used, some external naming scheme, right? So server exports some description of calls serviced on data ports, remote assignment ports, okay? Statically or dynamically. And client finds that information and uses it during the call. Okay, so this is another level of abstraction we're talking about, getting down to the nitty-gritty a little bit. Okay. So let's go and see now a flowchart. You generate a call message for call using exported information. Okay, somehow you marshal things. And ultimately some operation has to be invoked here. Anything in between?
So you need at least a service running on the person receiving the marshal call that has access to the naming scheme and can route the message to the proper area, and then something to invoke that, or to, yeah.
So somebody here to go and invoke this thing.
Right.
Somebody receive the message and invoke this operation. Anything else to be done here?
You need it. Where does it go back?
Okay, so let's just go in one direction first.
Oh, okay.
We'll go back in the next slide.
So you marshal it down so you have a call.
You'll also have to serialize your arguments.
So that was done here.
Yeah.
Okay, but maybe let's go back what you're talking. So going back meaning what? What do you mean by going back?
So where the
Data
result
has to
is
go back?
because you know that you're on the communication channel, but it's possible that you're handling multiple different exchanges over
Right.
the same channel. So you need to know where.
So ready to go back, and in Gypsy you can just say reply,
Right.
and that's nice, or send to last sender or sender. Okay. Anything else this guy has to do before sending the message? This thing that you guys will be doing for the next 2 weeks?
So
So it has a block.
Something there to go and some processing has to be done. Okay. So we'll just call it process call message. Okay, and it might go and decide, like in Gypsy, that you'll block for procedure calls, but you won't block. I mean, you'll block for function calls, but not procedure calls, or block for everything, or maybe block for nothing also is possible. Okay, potentially. So then we go and communicate call message on data port and handle any communication errors. Okay, somebody's going. That's your. You have to worry about these things. When you do a RMI, you could get an RMI exception, right? So some way that kind of handling has to be done. That okay, my message never got through, and you have to. So this communication happens at both ends, and process call message. That it has to go and maybe do some massaging here also. Let's just be on the safe side. Put a processing here. We'll see what that might be. Okay, and so in the return direction. You return a message, you return the value to call operation, and you can communicate return message to call a process. And again, you got to go and process here to unblock. Or maybe something else might be done. So I'm just general algorithm that before we send the message, we might do some bookkeeping and on the way back and on the way to and way back also. Okay? So that's another abstraction of what's happening. Okay, so we said that, look, this is the sequence of actions that has to happen. The method call gets transferred into this. And ultimately, there is the application at the calling site. There's an RP system at calling site, application at calling site, and RPC system at calling site. So what about the division of labor between these two?
So the first one would be the sort of marshalling. I guess the RPC system needs to do both the marshalling and any massaging of the data that needs to happen before it gets put on the wire, and then the app. Do we need to flip the RPC?
Maybe, yeah.
Okay, yeah. And then the RPC system at the quality.
I just copied this thing. Yeah, I didn't.
Reflective processing, so processing and then massaging needs to go on.
Okay, so that's the ideal system.
It would be nice.
That's one level. So there's two extremes possible. One is that the RPC system does as little work as possible. And the other is the RPC system does as much as possible. And you went and described the one that's as much as possible. And that's kind of unfortunate because you guys are implementing this. So you were just put some more work on in your plate. So RPC clients and servers handle all aspects of RPC. So that's one extreme, complete RPC awareness. Okay, and I'll show you an example, the Sun RPC, which was built for. So when I tell you guys that I did the first CRPC, I did the first transparent CRPC. Sun had come up with something called RPC that was completely aware, where the programmer did everything and they just did a few things. Okay, and I'll talk about that after we've talked about RMI. Okay, so. And the other thing is that RPC clients and servers are completely unaware of all RPC details, and the system takes care of it. Now, RMI, does it fall in this? Does it fall here?
Kind of, sort of. You have to at least handle the remote errors.
Okay, and I have to go and register.
Yeah.
Okay, so.
Of course, you really can't be completely unaware.
Sure, you can.
No, but how would you distinguish between remote and local stuff?
So let's imagine that I've programmed a JVM that when. So let's imagine I program a JVM that when I create an object, I create it somewhere else, and then my JVM is distributed. So the programmer knows nothing about how these objects may be communicating over.
But then you just took everything down into like the OS level.
Yes.
Your OS
But then
is
the
by
programmer doesn't
default.
even know Jack.
Your OS is by default not distributed.
Yes.
But now you're dealing with multiple.
I did say this was a good idea.
Oh,
I said.
Do you think anybody would ever implement something like this?
It's like X Windows.
Cedar.
When you use
Xerox guys. Xerox guys implemented something like this. I've actually used that system.
What's it called?
Cedar.
Cedar.
Yeah. Cedar.
The tree.
So Mesa was the first language, then they had Cedar as a successor to it. Mesa had strings, Cedar had ropes. So
That's petty.
that's all I remember of Cedar. They had a paper on Cedar, and I couldn't figure out how they were different from Mesa. But they got it published in IEEE Software Engineering, I remember that. And the only thing that I remember is that they had something called ropes. Okay. Gypsy supports a wider spectrum. To some degrees, it's closer to, it's more transparent. It doesn't require you to have a remote interface. But it exposes a lot. So you also go and see the aware layers. Okay? And the question I pose is, can one have complete transparency, which you guys have already kind of answered? And I said we'll wait for this too much later. Okay? Because right now I want to get as quickly to the synchronization parts that are relevant to your assignment as possible. Okay? So RPC versus RMI. Asad, RPC, OO or conventional, RMI, that's what we'll use as our. Okay, so RMI is only O and RPC is broader. So that's a separate issue. Okay, and that has to do with transparency. And O examples, we're going to take Java RMI, we're going to take Gypsy RMI, and Gypsy RMI is something we can play around with, so we'll use that for the detailed implementation. Okay. Now we've got a couple of minutes. Very quickly, what do you think is the difference between, from a design point of view? What have you seen as the difference between Gypsy and Java RMI? Having used both of them.
Because Gypsy defines serializer factory and custom serializers for everything, it doesn't need to implement serializer, and hence it doesn't need to work only for remote things.
Well, Gypsy needs to implement a serializer. It just allows. I mean, if it's going to have RPC, it's better have some serializer. It can't tell the user to write it.
Exactly.
It does come with something.
Yes.
Gypsy's more of a framework than it is like an actual Java RMI is sort of hard coded. You can't touch.
Okay, so one of the big differences is extendability.
Yeah, but Gypsy you can hot swap pretty much any module.
Right. But before you saw all that stuff, when you just used Gypsy RMI, you were just an end user, right? You didn't know what were the differences you saw as an end user.
It's very port based versus client server based, it's not host based. It's more port based.
So ports, as an RMI user, you have to know about ports.
Yes.
That's one thing, right? And that's kind of related to the fact that it's all a framework also. Anything else that comes?
Why did RMI require things to be sent across network to be remote? Why was that, and why?
No, hang on. RMI means remote.
Java RMI.
Yeah, means remote.
Everything that needs to be sent has to be every remote object needs to implement a remote.
And do you guys remember why it had that? It was a check for error handling, and error handling.
It forces handling remote exceptions.
And it also generates the proxy, I think. So if it extends remote, it has to generate the proxy.
No, that's the export object.
No, that's the export object.
Yeah.
That's the unified remote object.
So
Like that interface.
So that's one difference.
Tag that
So we are going
the
to.
system used to say, oh, you need to have.
So how did Gypsy work without it? That's the main difference.
So I'm glad you're asking all these questions because you won't be completely bored in the next three or four lectures. So one difference we saw, and I'll just stop. One difference we saw was that the ports are very visible to you. Okay. Second difference we saw was that you don't have to have remote implemented. How it does it, maybe just some magic or whatever.
No, exactly. That's my question. How does Gypsy handle stuff that is normally handled by handling Java remote exceptions? Yes. How does Gypsy do that?
Gypsy, you can always catch the exception. You can always define remote and catch the exception. You are not required to. If you don't do it, then Gypsy will handle it for you. I'll tell you that a little bit. But at least it doesn't require remote, right? Somehow, whether it's good or bad is another issue.
Right.
Okay. So we'll continue with this next time. We'll talk about the basic design differences, and then we'll look at the implementation. Hopefully, we'll get to some aspects of the next part. We've lost 10 minutes. But the delegate answer was at least answered.
That has changed my life, actually.
That's what I wanted.
And the next part's due in 1 week.
Did you just say
Yes.
Is it?
And sorry,
Sorry, I was talking to you.
Thursday,
Sorry.
next Thursday.
Next Thursday is an algorithms midterm.
We decided on this much long time ago, and we have a Tuesday. Thursday night. You guys what? You work anyway after class, and were you guys all here last evening?
Yeah, that was.
I went by here and I thought I recognized some faces here, and I said, "Oh, good. This makes me feel good."
Well, the system Hard. Parallel.
So, okay. So we are looking at RMI now, okay, and in particular Gypsy RMI. And what you did, of course, is not RMI, it's still data communication in your first part. But this will be used, but it has synchronization. And what you're going to do ultimately is use this synchronization to do synchronization in RMI. I've got an RMI, I mean, in the Gypsy, in another version of Gypsy RMI. Okay, so there is a Java RMI, there's a Gypsy RMI I've implemented, and there's the one you'll implement. Okay, and the one you'll implement will be more synchronous than the one I've implemented, and it'll use your receive to do the synchrony. Okay, that's the basic plan. That's how they were crafted together. So let's go and understand what I have given you in the Gypsy RMI. We saw last time that there's difference between Java RMI and Gypsy RMI. And, Java RMI is designed for duplex communication. So there's a lot of design goals that are different, that are separate. I want to just show you the features first, then we look at the implementation. So this is for duplex communication, and it has some features allowing its customization. Okay? One of the things I remember seeing at one point, and you may know this better, is that you can actually pass to the RMI layer your own socket. Have you seen that? Anybody seen that? So I remember in the back of my mind that there's some feature. It should exist if it doesn't. And then you can use the socket. You can go and try to do socket operations and allow RMI operations on that. And of course, beware what happens, because the same channel is being used. And in Gypsy, firstly, it's designed for duplex and group communication. As somebody who does research and collaboration, I have to worry about multicast. And anyway, networking people also talk about multicast. So it was meant for this too. And so that's why some of the issues that you see as maybe problems in Gypsy are features if you think of group communication. Okay? And again, I didn't design it for anything other than teaching this course. Okay? I've been teaching operating systems for the longest time. That was my way to introduce systems to graduate students. And like I told you, firstly I got bored, and secondly, dealing with C programs is not a pleasant thing. Okay? So I had to go and revamp and think of what course I might want to teach, and decided I'll teach distributed computing. So I wanted to teach it again in a very implementation-based approach. So I designed it for that. Okay? I don't know if there's any other source code. I did a Google at one time. Is there any RPC source code available on the web? I didn't see anything. So even if you hate the design and hate the implementation, at least the source code. Okay? Whether it's commented or not is another issue. And more important, and this is something, by the way, I mean, Rob gave you guys all a zip file. Please don't use that zip file. Okay, take my project, include that in your code, because you can't edit that.
Jar file?
Yeah, that jar file. So, by the way, if any one of you guys, all you guys can help, did you ever figure this problem out during yesterday's? You didn't. You haven't had the. So I haven't. Within 10 minutes, I couldn't solve a problem she had, and maybe you guys can help do it. But I might have made more headway had she included my project. She's doing class for name. In the main method, if you do it, it gives you fine. However, if you do it later in a thread, and I don't think I changed the class load of the thread, you do the same class for name, it gives you an exception. And I can't for the world of me figure out why that happened. And I was going to just go and see in the Gypsy server. So in the server, when you get a client object, the server has to go and convert the name of the class that was passed to a class object. And for some reason, she's getting RMI/RMI client not found, the file. And it just makes no sense to me, because I tried it out in the main method, it works fine, but in that thread, it's not working fine in the same process. So she was going to try it on some other computer, but we saw that there are these computer-based issues, and that's why one of the bugs that I had did not get found in the debug mode, the one that you helped find. Just because what happened really was, I assume, and I think I also always tested in the debug mode. Can you imagine why it would never manifest itself in the debug mode? Did you guys see his answer?
I wanted to know how that happened myself. Yeah, how is it something that only happens in debug?
For me, it manifested in debug if you step through it.
No. In debug mode, all of you guys said no, and I never saw it either. It was only in the runtime mode. So I had to debug it without the debug mode. And it's basically that my theory is that the fields are returned in different order in the two cases. And this was the add field, add method. And the add method is alphabetically the first. So maybe in the debug mode, add is coming That's my best guess of why it happened. And I never run anything in the run mode. So I don't even know how to do the run mode, in fact. It's just F11 always. And it's control F11 for run. So maybe there's something going on here and there's a bug, but I just can't for the world of me figure out, because I do not believe I changed the class loader. And even if I change the class loader, if the class is already loaded, it shouldn't. So I load the class first in the main method, and then it's trying to do a class for name again later. It should just look at the cache and go and say, oh, I've already got this loaded class. So it's just bewildering to me. Anyway, so had I had the source code, I might have been able to just do some more debugging.
The job should have the source code.
I know, but you can't change it.
Oh yeah, you can't change
I wanted to go and put this statement, class for name, in every place in the path to say where it's suddenly failing.
Okay, yeah.
And you guys had to do this anyway because there was a bug. Remember, there were 2 bugs in Gypsy that you had to fix. One was the serializable thing, and the other was the limit. No, not the limit. There was some other bug also. There were 2 things you guys had to change. Okay. And by the way, I have changed them in the zip file. If you want to reload it, it's changed.
The other thing was a transient.
Yes. That was an object editor, and now I've made it resilient to both browsers. Okay. But the main point is that even though it's source code, I mean, it is meant so that you can extend it without source code, and these are all your factories and so forth. Okay. So you shouldn't have to. My theory is that you shouldn't really have to change somebody's source code to change the functionality. Everything should be through registries. Okay. And that's when the API comes in. And like I said, there's just I'm behaving like a startup mobile computers. Okay, so what are some of the differences? Even though I think a socket can be passed to the RMI layer, RMI really tries to go and hide that layer from you. Okay, none of you knows it, and I think I once saw it, and I don't even know if I can reproduce, where I saw it. So the whole idea is that this is a black box underneath. In Java RMI, in Gypsy. I'm saying this very definitely because I think, Gypsy layer visibility, the whole idea is that this is one more layer in a stack of layers, all of which could be visible to you. Okay, you guys know there's a byte communication from implementation at least. You know there's a data communication layer on top which hides the methods here, like you guys have said. And actually, when you say I'm doing transparent, so there is no free transparency. If at some higher layer you've got transparency, that means at some lower layer you've got awareness. Okay, if your chauffeur is driving, yes, you are transparent to the traffic, but your chauffeur better not be, right? So there is an aware procedure call layer also, okay, and it's there if you want to use it. In fact, so there's all these layers are visible, and whether you want to see them or not is another issue. Okay, except that this layer really does hide this because of what you were saying, that you can't implement the same interface twice. Okay, and again, why are these layers visible? It's consistent with my being able to teach it as used as a teaching vehicle. And what does it really mean to be visible in practical terms? That I can use the same layer, pass objects on it, and pass procedures and make procedure calls on it. Okay. So in fact, you guys could have not just extended the duplex object port, you could have extended the RPC port also instead. Okay, but it's nice. Now you can build an RPC layer on top of your this layer. Okay, synchrony. So what's the difference between the synchronization in RPC in Gypsy RMI and Java RMI?
Gypsy's asynchronous.
The procedure calls async. Sorry?
Yeah,
Optional.
It's optional because you can change things. Everything can be changed. So I'm committing to nothing, right? So let's go and see A, what you can change, B, what is the default semantics. So RMI is integrated with local procedure call. So that was the whole point. So if local procedure call blocks you, you block also. Okay, clear semantics. Gypsy, make it wait. By default, it should wait only if it needs to. Okay, and nothing really needs to, but because even in function calls, you could go and get them later asynchronously, results. But remote function calls block depending on configuration. Okay, you can imagine a configuration where even they don't block. And remote procedure data may or may not block depending again on configuration. Okay, but by default they don't block. And there are a lot of aspects of configuration, and there's a lot of. So, as it turns out, depending on whether this layer is okay, let's go and use our laser pointer. depending on whether this layer is blocking or not, you might get some blocking even at this layer, as we know, with sockets. Okay, so as it turns out, the default implementation is Java NIO in the non-blocking mode. So literally, you should get. I mean, what did you guys find? Was the performance of Gypsy RMI almost as good as I guess it was serialization as the NIO performance? Probably not, right? Do you guys remember?
NIO so far.
Sorry?
NIO has
Fastest. So in Gypsy, there is a serialization overhead, and there's of course all the layers. And by the way, one of the assignments I gave last time I taught this course was to change NIO to sockets, the layer to sockets. Okay, so they learned more about this interface other than NIO. So I decided that this time you guys should just learn about NIO as such on its own, even without the context of Gypsy. There they learned about sockets in the context of Gypsy. Okay, so that's the assignment I didn't give this time. Some text you can read later. Do you really want me to read the text? But that text is good, right, for later? You know, it's very interesting. It's easy to create text slides, as you guys know, right? And it's just so boring in class because there's not enough mystery, really. And it's so useful when you're studying for exams because you don't want any mystery, right? You want to understand all that stuff spelled out, and you don't want to go and listen to the recording, and that's so slow. So that's my compromise, that I just could put these text slides in, and someday I'll write a Word document on this. Okay, so what do you think I'm meaning here? Big words I'm using. Reusability, error checking trade-off.
With reusability.
So does RMI reduce reusability to some degree? Reusability meaning what? If you're building a distributed program, what might you be reusing?
You can reuse data channels. So like if you establish a connection between two things, there's no need to tear down and remake a new connection if you want to send a different type of data.
Okay, so you're thinking distributed program, you're saying going from one type of data to another type of data. That's good. I mean, it's always good to ask these questions. But what if you're writing your first distributed program, or you're taking something that was non-distributed and making it distributed? You'll be reusing the non-distributed program. I had a counter, I want to make it a distributed counter, right? I had Word that runs on fully on this computer, I want to go and run it from the web, right? Or something like that. So does RMI allow you to just reuse your existing non-distributed objects? If I had a counter, can I just use it in a distributed fashion? Just make stuff remote, you know. So if I don't have the source code, if I don't have, you know, so that's the truth. Okay, it's not intellectually. There should be an Eclipse plugin for that, or Eclipse command for that also, right? Yes, absolutely. I mean, that's okay. That's what you guys should do now. You can easily add plugins to this stuff. So
You could delegate. You could follow this delegation pattern.
Always delegate to a remote. There we go. There's an Eclipse plugin.
That's what you do. You don't have the source.
Yeah.
You wrap it, and then you put all the shim code around it.
Right.
And track
So a special kind of delegation you guys can do. But anyway, you have to do some work, okay? And that's a trade-off, right? Why did we have remote, insistence of remote? Error checking. We want to insist on the programmer. So caller and callee are distribution aware because of requirement to handle special remote exception, okay? This was a requirement, and you can only generate proxies for remote methods. That's a rule there. And if the caller is just going to print the stack trace, I mean, that the interpreter would also do for you, right? So there's really no need to catch an exception if you're just going to do print stack trace. So you cannot reuse existing software without changing it or creating a delegate there. So I really shouldn't say without changing it, without doing a lot of. So that's Java RMI. And a consequence of that is that you cannot call object methods remotely, right? You can't call equals remotely. You can't call toString remotely. And I wanted to give to object editor. I wanted to run object editor on my computer and run the program on another computer, the object being edited on another computer, and I want to be able to go and edit it remotely. I can't do that with RMI because object editor call uses toString all the time to go and determine how or the display should look like. Okay, so I had this in mind also. So I say you make the trade-off, programmer, whether you want reusability or you want error checking. And what would that really mean? So where Java RMI insists on everything that is called remotely be a remote method, throwing an exception, what would I say?
Oh, as long as it's serializable and I can send it to the other person.
Actually, do I need it to be serializable?
I mean, as long as you have a pattern serialized.
As long as you have a serialized register for that.
Yeah.
Or it's just serialized.
No. Why do you guys talk of serialization? I mean, yeah, for the parameters of the method, sure. Right.
You
But-
don't need to serialize the class. You just need to be able to serialize the method.
Serialized by
Which I can just build some data structure for,
Yeah, exactly.
right? So how do I make sure then? So if I'm a designer of a remote object, and I want my clients to really do the exception handling, how can I get that feature now? I want to have my cake and eat it too.
It's going to be hard because the error you're going to get, if it's communication related, is going to be some general thing from the communication layer. It's not going to be very
You can
specific.
just call the interface, make the interface methods through a remote exception. Just like
Well,
If I do that, then I'm RMI.
yeah, where you're trying to not have to do that.
So how can I have it both ways?
you can
Who's going to make the choice? The choice is not going to be the programmer, who we don't trust, the client who we don't trust. It's going to be the designer of the object. That designer can decide, you know what, I'm going to reuse this counter. I don't care whether.
designer of the object and the interface, right?
Yeah. Designer of the class and interface
I mean, I
of the
guess
remote object.
you could have it so that your messages that you send have they have the return value as a field. You could also have like a field for exception.
Yes.
And so then when you get that message, if you see that the exception field is populated, then you can just throw that.
No, but how do I force the client of that object to handle exceptions?
Oh, you like a checked exception?
I want as a designer of the remote object, I want either my clients to behave or I don't care how they behave.
I don't know how you.
So if you want to
check
force
exception.
them to behave, then you should just have to throw the exception.
Well, I mean, I'm saying.
No. At compile time, at program writing time, they have to go in.
Yeah, like I can get you.
So the answer is much simpler than is coming out. Okay, firstly, proxies can be generated for all methods of an object. This is the fun, if you want it, you can do it. Now you have to tell somebody what methods you want proxies for. Okay, how do you specify that, by the way? How would you tell Gypsy that which methods you want should?
Transient.
No, transient again is to do with serialization. So even if it's a transient method, you could call it remotely. You guys, when you said generate proxy, what argument did you give to the proxy? Generate proxy. So I can just give a class name, and when you set class name, which methods of the class do you think proxy was generated for? All of them. You could have given an interface that was only subset of the methods.
Oh yeah, that's what I did.
Okay.
Remote client and remote server.
Right.
They were interfaced.
So the proxy generation call takes as an argument a type which defines the set of remote methods of the object. Okay. What this does is I generate. So even though the remote object might actually have more methods than this, we will generate proxies only for these methods. Okay. And what Gypsy does is it goes and looks at the class, sees what interfaces it implements, generates proxies for all of them, then goes to the superclass of the class, see what interfaces it has. It's just the way reflection goes. I can't just get all the interfaces at the same time. And then it goes and generates proxies for all of these things. Okay. And also it generates proxies for. Now, what should it do? What about the methods? So I said interfaces. What about the methods in class object? Should I generate proxies for all of them, or some of them, or none of them? What if you were designing? What would you do?
From object,
Yeah.
well, some of them will kind
Okay, so which terms don't make sense? Huh?
Hash code.
Yeah, so like the identity hash is only guaranteed.
No, identity hash code is actually system.identity. It's not an object method.
Yeah,
No, object identity dot hash code.
well, yeah, but
Yeah.
it doesn't have identity hash. Yeah, the hash. The
Hash code. Hash code. Does it make sense to forward it?
No, because it's not guaranteed to be.
The same on both sides. It doesn't have to be. In fact, it probably should be.
Okay.
I just see there being problems if you're allowed.
What other methods and objects are there?
Equals.
Should I go and forward that?
No, because that does.
If you don't forward it, we'll just check with two proxies are equal.
Yeah, but if you forward it, that still doesn't make a whole lot of sense because doesn't equals have to do with its location in current memory, like on the host?
Remember, we had an example that supposing I have two counters in the remote end, they're equal to each other. Now I have two proxies to the counter here. Should the two proxies be equal to each other? The two remote objects are equal to each other, right?
It depends on the requirements.
But I don't know why you would do equals if not for what I'm talking about. Why would you want to check if two proxies are equal to each other? In fact, in Gypsy, I will not generate two proxies to the same object. I will always give you back the one proxy that is. But why shouldn't I do it that way? Why should I have two pointers to the same object when I can have only one pointer? Because you just want a proxy to the remote object, right? Why would you want to create two objects that point to the same object? Okay. You know, one of the when I said, you know, I like teaching operating systems because this is why I got to teach you guys systems. I want to tell you guys this, that, you know, I've been to Microsoft and I got frustrated by the industry, even by some of the researchers, but certainly some of the industrial people there, because they won't question too much what they get. They spend their time trying to copy, try to basically keep up with the startups, with the other people who are innovating and saying, oh, nobody else does this, so why should I do it? That was their way of progressing. They didn't look at Microsoft research. So one of the things I want to tell you guys is question everything. Okay, and just because Java RMI has it, you know, and just I'll tell you another story. I went to also worked in India for one summer, and I was working with on some software engineering project, and there was this new engineer. She was like 22 years old, just new, and I was told go and learn from her. Okay, so I sat down with her, did some pair programming, and of course I learned a lot from her. And then people said in the end, what did you learn from him? And every time she would say, this is how it works, I would say, why? And she'd get very frustrated. She said, yours is not to question why. And this is how it works. And in the end, she said, that is what I learned from him, to question everything, you know. And that's how you can make progress. So, you know, why should you in RMI send two different proxies when you can send one proxy, right? So just think through those things. Okay. That's why I like the Google approach that, you know, you try to go and combine research with development so that you're trying, whether you're a researcher, whether you're a PhD or not. Okay. So, what other object methods are there?
Class, get class.
Okay, so that is just going to return the same thing, so there's no point forwarding that.
Not really. Get class will return the proxy class for there, and it's going to return the class of the object.
Does it return the proxy class?
Ooh, you're right, it does.
No, but only if it gets forwarded. But if you do
Yeah.
get class on the proxy, then it's going to return the class of the proxy.
Proxy knows what the class there is. It could go and send. I don't even know what I do with get class. Just try it out sometime in Gypsy. I honestly have forgotten whether I thought about it or not.
Get class is important because the
Yeah, maybe I send the proxy. I give the proxy. Because there you might want to know whether I'm a proxy or not. How else? Actually, there is an is proxy method. Okay, and so that's a good one. I've forgotten whether, you know, about that issue, and I handle it somehow. Two string?
Well, yeah, that's almost always isn't always overridden.
So you should go and forward. Otherwise, you're going to get the proxy implementation. For the same reason, equals should be forwarded.
wait,
It's true.
notify,
Wait, notify.
Okay, so what does it mean for me to wait on the remote object? The lock is there. I'm here in a thread here. So wait, notify, I don't send across.
Why not?
Notify. Because how will I implement it?
That would be murder.
How will I implement it?
Now that is an interesting question. How do you
Because the thread here will have to go and wait on the thread there. Which could be done. I mean, I'm not saying it can't be done. But-
The naive implementation would have it wait on the on wherever like the callee like we'll have that wait, but then you're free to do whatever you want. You don't block.
Or you block on the wait call there. I mean, you
Right.
could do that.
No, you blocked because you were waiting for the main object.
What I'm saying, if all you're doing is you're serializing the method call, you know, happily serialize the method call against the other end, and then your whatever your infrastructure is on the other end will call wait because that's the serialized method on.
Also, just imagine is this thread worrying about data structure there which can't even access? Why do we do waits? We build critical regions, right? Critical data structures. So this thread here is waiting on a data structure there, which it can't even access. So why is it waiting on that? Just from that point of view also. Sure, a thread there should wait.
Yeah.
That represents this guy. But so that's the reason why I don't do it. So anyway, so again, if you question these things, you have to answer these questions. And currently, proxy method is generated for equals and toString without option to disable this right now. Okay, and actually, there's a little hack or a feature here. So I don't want to call toString too many times. Right? So every time you call toString, and the funny thing is that you're debugging something that's maybe deadlocking, and you call toString and it causes a deadlock because it's going across there, right? So what I do is, what I want to have my cake and eat it too.
You cache it, don't you?
You know that, or did you see that? Or?
I guessed it as soon as you started talking about it. I'm like, well, you could always wait for the person to call it once and then cache the answer.
And when do I refresh the cache? I mean, I've been crazy.
That's a great question because, well, maybe if someone calls a setter, the next, or like calls something that, like a write method on the remote thing.
But, so I'm on this machine.
Okay.
toString was called there. How do I know that guy might have changed toString? I mean, we don't know.
What I'm saying, so like, your sync client or whatever caches
The toString value first time. It does that.
Yeah, caches it.
Yeah.
And then.
And it does the same thing with hash code also, by the way. I don't know whether I think it does the same thing with hash code also, but I'm not sure. Okay.
So like, and then if you do something like if you perform a write.
On where?
Like if someone calls a write method from this machine, calling it on the call.
Fine.
Then you say, okay, next time someone calls toString, I need to rehash it.
Beautiful. And what else? Any other reason? Remember, I'm talking group communication.
Yeah, if you get a notification that someone else is called.
So what I do is, if any message goes from my computer out, or if any message comes into my computer, I go and refresh the cache. I just go and invalidate the cache at that point.
True. I guess even if you call a read method, there's no guarantee that there's not code running on the read that changes it. So,
absolutely. But this is my hack. My it's better than, at least it's better than what RMI has, which is always going to send the toString of the proxy, and which is always going to be the same value. There are times when I'll give you the wrong toString, but it's no worse than what RMI does, which is always give you the wrong toString. Right? And so that's what I do, and this is where I use my message bus. That I just listen to the bus events, and my cacher just goes and says, has there any event been occurred here that is a message in or message out, and it kind of. Question? So I'm saying not hash code, wait and notify, but these parts are something I could make flexible, but not some. The other thing is that, of course, you guys, if you're using RMI, you have to go and build your own group communication mechanism, right? Just as this shows that you go and keep track of all the clients, and then when the message comes in, you go and send it to all the other clients or everybody, and this is built into Gypsy. You can say others and all. Okay. So free programming. So RMI designed for duplex communication, and Gypsy. There's byte communication, type data, aware remote procedure call, transparent remote procedure call, and then you have group at all levels. Okay, and we touched on this last time when we talked about serialization. And in particular, there's group remote procedure call, and this creates some semantic issues which we'll get into at some point. Okay. Sorry?
That sounds like a nightmare.
Or it reduces nightmares. You just go and say send all, call all. Okay, we'll see what that means. So this was a cause of confusion to many of you, that in RMI, there's a shared object between the caller and caller. This is the RMI registry. And the protocol is that an object is deposited by the callee and then is. And what do you guys do instead? What's the architecture in Gypsy? To achieve the same function. So when you want, how do you get a proxy here? You go and look up and register. Look up from the registry.
In Gypsy, you say, I want this object from the server, and the server creates proxy for the object and sends it through. You don't have a room, but it maintains the registry.
You have to create the proxy.
So rather than looking up, you create the proxy.
Yeah, like on your client end, you have to create a server proxy. On your server end, you have to create a client proxy.
You don't have to create the client proxy at server end. No. That was something I did if you wanted to. I mean, I'll show you why I did that, but you can just pass the object. Just as in RMI, you can just pass the object. In a.
I think he means that the server has a client proxy, means that the client proxy is generated automatically because the server has a list of the clients. And the clients are storing that as proxies.
Okay. So you're talking of Java RMI or Gypsy RMI? In Java RMI, let's just understand, see if we understand that. The callee creates a remote object, not a proxy, and then register the object here, which essentially results in a proxy being created here and serialized here. And then the caller goes and gets the proxy from here. In Gypsy, one interpretation is that you have the remote object here. You just contact the remote server here directly and get the proxy from them. That was Derek's interpretation. Okay. And Rob, is your interpretation the same as Derek's interpretation, that the remote object is created here, then the proxy for it is created here, and you copy the proxy on here. And when you guys go and say create proxy or get proxy or whatever that method is, it contacts the server and gets the proxy. Is that your understanding also, or is that everybody else's understanding?
That was not my understanding. When I built my client in Server Launcher, I did their opposite in my create proxy method. So on my Server Launcher, I created a proxy to my remote client.
Yeah, just forget about that. You didn't have to do that. So just forget about that. Okay. No, but just talk the other way around now. So the client, you had to create a proxy for the server.
Yeah, I did that.
Okay. And the client went to the server and got the proxy from there?
I just generated it.
Did you generate or look up?
Look up.
You should know better. You faced a problem because it was not lookup.
What do you mean?
Why couldn't you use the proxy till you did the connect? You could not access the proxy after you created it. You couldn't call any methods on it.
Yeah, I
So you
ran
only
it.
did it in the creator, I guess.
Right? That's what you guys got burnt by. You had to do so. Did I get your? Okay. So basically, the proxy was created, perhaps even before the remote object was created.
Because you assume that an object is going to be there in the future.
I assume an object is going to be there in the future. And only after you were connected did I say you should use that proxy. Only in the do post connect operation or the create UI method or in the connection listener could you go and use the proxy. It's only at that point you know a connection to the other end exists. And hopefully the connection to the other end exists after the other end has gone and registered its objects. So I am being far.
Multiple proxies are created to the same object. But the
No. Where? In which system?
Okay, so there are multiple clients,
Yeah.
right? And there's one server object, right? So there are multiple
Proxies in different clients.
Multiple proxies in different clients. Now, when the server object is created, how do those pre-existing proxies suddenly connect to the server? That's my question.
How does a client
How
connect
does
to a server?
okay,
How does a client connect to a server?
Three-way handshake.
Just a connect method.
Yeah.
And then you have a connection listener.
Right.
When the connect listener is called, we know connection is established.
Yes.
I'm saying every client should go and, no client should go and access the proxy till the connection has happened. That is what you guys in Piazza have summarized, and you know that's what.
Exactly, but the connection happened, right? But then why do you say that the proxy exists before the object is created?
Proxy exists. You do a create proxy, you will get an object.
But you have to call any specific connect on that proxy.
No. Just don't use that proxy. You don't call connect on the proxy. You get call connect on the port from which the proxy was generated.
From which the proxy is generated.
So the proxy knows about the port, and if the port's not connected to the remote object, then calling any method on the proxy is useless because then it'll try and send the method over
So
the
what
port,
if the
which
proxy
is
is created and the port's connected, but there's no object on the other side?
Oh, then there is server probe. Server went in, allowed connections before registering the remote object, which is its bad. Okay.
that all fits.
So why not just go and do it this way? Just because I want to be different?
It's another level of indirection.
It's a level of indirection. What about binding? I have more flexibility with my scheme, right? The proxy can be generated before the remote object. Is that?
When you have an explicit step where you're saying, okay, I've got the object, I'm going to create it.
It's
a
very.
proxy for this object, and
it's-
I'm going to put that on the registry. And then this way, you're like, I'm going to create a proxy for this, and if someone wants a proxy to this, I'll go ahead and create the object.
Or, yeah, you can think of it that way. That the destination of the proxy is not bound when the proxy is created.
Right. It can point anywhere.
Now, why would that be? Because that's the key. It can point to anyone or any set.
Well, let's say you're sending your method call over a port. Well, if that port happens to be a group port, then for free, you're now communicating like broadcast or broadcast or however the port's configured.
So I have a proxy generated for the whole group. And I'm the first one there. And when the first one, it doesn't go to anybody. As people get added, it goes to all of them because there's a level of indirection and I could create the proxy earlier. That is that. So because I was thinking group communication, I went this way. Okay.
It also gives you the advantage if, for some reason, the port needs to reestablish its connection to the other end, and it gets like load balanced to another server or something.
Okay, that's good. That's good. I didn't think of that. Or actually, I do have this in fault tolerance also, that the proxy could go here or later. Yeah.
Yeah, but that way you're not bound talking directly to this server that has this object. You can send it over the port, and if the server at the remote end is okay to handle the connection, then it should handle the method call fine.
Say this is all good. Proxy can be created before callee object. And as Asad found out that when he was calling the proxy methods, and some of you others also found out, those were saying RPC on unregistered port exception or disconnected, things haven't happened. So that is the flip side. And enough of you had this problem that this is a real problem, right? If you don't understand it. But what I get instead is I can have a peer-to-peer session. There's no notion of one guy being the server, the other guy being the client, and we can just establish proxies and then they can just talk to each other with some risks. Okay? And the basic thing is that I can build on top of this infrastructure an RMI server and lookup. I can easily go and create one object that you guys talk to go and get existing objects. Okay, in RMI, one of the problems is that there is two ways to call remote methods. One is through RMI. The other is through this magic scheme where you say registry.lookup. When you say registry.lookup, a remote method invocation is happening to the other end. But it's being done through these static methods and you don't even know how they're implemented. I can now implement my registry.lookup using my scheme. Okay? And we know exactly that both of these things are underneath, converging to the same thing. Okay?
You can even create a distributed registry like that.
Which is what RMI registry is.
Yeah.
It is a distributed registry. So we can do that and we can have, what I mean is that registry is something you could create. Today in RMI, you can create a distributed registry in RMI also, but that will have to use the current registry. You cannot disable the current registry ever. Okay, and this is getting to be maybe a detail that I shouldn't talk about at this point, but in RMI, you can extend. There is the marshalling and serialization are connected to each other. that the RMI marshaller just goes and extends object in the output stream and does something special for marshalling. Okay, so it will send a remote reference. It does. And there's an is-a. The marshaller is a serializer. And in Gypsy, what would, if I was doing things right, and if I have that delegate button here, has a. Okay, so that's just something else. I forget this little box here. So that's something else that's different. So in terms of API, I'm just summarizing here what can happen. And also there's some small details that with each end there's a client name. Okay, and that client name is visible to the server. And when the port is created, you pass the client name. So there's just one more level of something else that happens here. Okay, so this is mostly and extensibility. It's layered, it's extendable, and you can have both kinds of layers. There's no global registry. I'm just summarizing. Not magic has it other than is a, and not hardware. Okay, so I'm just totally summarizing here. Okay, see how it works. Okay, and not how Gypsy RMI works, but how RMI in general might work. Okay? That's the implementation thing. So we know, what do we know so far about implementation? That there's a remote object, there's a proxy, you call a method in the proxy, the method here gets executed. Okay? So what's the magic that's going on here? That's that. And we also know through Gypsy, also by common sense, that there is some data communication channel going in here. They're called server and client ports in Gypsy, but there may be server sockets and client sockets here. Okay? So we know that much also. So the question is, what's in the proxy? We don't quite know what's in the proxy. What's in the client end, what's in the server? So first, let's go, before the communication happens, let's look at the setup. So remember that you have to go and export some external description of calls serviced on the data port. Okay, that's something you have to do if you're a remote server and you're using RPC. Somehow you have to go and say, these are my remote objects. Okay, and you guys just went and said register remote object. Okay? And anyone know what that register really did? I know some of you had to learn it the hard way.
In which?
In Gypsy, when you just said register remote object, what was happening?
There's a hash map story.
Good. You saw that.
Yeah.
Okay. There's a hash map that maps what to what?
Maps the object containing the class name.
No, so it's got to have a key and a value.
Yes.
What's the key?
Key is the object.
No, a name.
It's you have, when you register, you give it a name, so it has its name mapped to the object.
Maps to the object. Okay. Now you may not give it a name. You might go and give the class name, because I'm just lazy and I don't want to create. I just say, I'm going to have only one class of that type there. So let's use the class name as the object name. Okay.
I saw two hash maps. One's from the
RPC registry.
Serializable to remote.
Oh, that's another thing.
That's another thing.
Okay, that is my proxy business.
Okay.
That's complicated.
That's
Sorry?
No, but the thing is that you had this one application where you actually had two counters registered. Weren't those of the same class?
I did. Then I give the name. I can do all of that.
Oh.
I can go and say a name or a type or just an object from which the class is derived. And then I can just go and, given a name, I can find the object. Okay, this is just a local registry. This is not some other process. Okay, so this is just I've talked about this. Okay, and there's no mystery here. This is the simplest part of Gypsy is this. Okay, you just have a table. You look it up and you store it. And we don't need hash code table here. We have strings, no problem. The other table is the complicated table. So this instance of it is kept by port of callee. So when we were debugging your counter, we went to this table and found that the object was not registered. Okay. So what's going on? You have a simplex object port and simplex input port of client end. And you can create a simplex RPC client input port that's a subclass of this. Server input port is a subtype of this. And it's also a subtype of RPC registry. So all the methods that you can invoke on the RPC registry, you can invoke on the port, and you can just say port dot. I've hidden a lot of things from you. You just go to tell the launcher, register it. But underneath, this is what's happening. Okay. And in the case of duplex, you can go in, register, even at this end, you can go and register things, and you can look up. So, okay, now something that in case any one of you is still wanting this question answered for the assignment that's due today, this will help you to some degree. So, I am allowing remote assignment and remote procedure calls on the same port, right? That means I have the messages going from the user on behalf of the user, and I have messages going on behalf of the user and messages going on behalf of the RPC system, back and forth, right? So how would I distinguish between these two kinds of messages?
You give it some better information.
Like some special bit string?
Yeah. So this is an assignment. This is a procedure call. Please serialize it as such.
So what did you guys do? Then you went in. So how did you specify this is a procedure? How would I specify the procedure call or a return value?
Give it its class name. So
Just use class names.
Give it a wrapper class for each one, and then the class name is the person who gets sent along.
Exactly. We have the serialization working underneath us. Just choose types that are defined by you. If they're defined by you, they have to be unique. Nobody else can define the type with the same name, and that type, and that's what you have to do in your synchronous receive assignment also, right? You have to go and pass some messages back and forth.
I thought if we delegate to the object port, we can just get objects straight out without having to do any of that.
No, but how do you distinguish acknowledgement for a? So your reply has to wait till the client, till the other end has gone in. Receive. So what's the receive semantics? Sorry, the receive has to wait for the message. Okay, so you guys don't need that, right?
Oh yeah, so we're just doing objects.
Yeah.
So
What were all your questions about then? Oh, because you were doing send wait.
Well,
Yeah.
our problems from before was because if you don't delegate, you try to extend, then your own message received, because it registers itself as a listener, gets you a byte buffer for the message instead of an object. And we were trying to figure out how on earth we got an object.
Oh yeah, but we solved that problem.
Yeah, we solved it by delegation.
Yeah. Okay. So I guess you didn't have to face this problem. Okay. Well, you just use special Gypsy types for messages. Okay. And Gypsy, your receive listener will somehow trap these messages, and it'll say, okay, if it's my kind of message, I will do my kind of processing. Otherwise, I just give it to the user. Right. Okay, and of course you want to make this all extendable. So so what do we have to do? We have to return we have to generate two kinds of messages: call and return value. Right? And Derek knows better than he wanted to know. So my RPC return value is a type, and what properties does it have? What do I want to, what are the various, so that's a type, okay?
Object, method.
So I'm just return value right now. The easy part first.
Return type.
Just return value, just an object, right? And I vacillated between making this a serializable or an object, and because I was vacillating, you had the problem on your Macs. Did you guys also have the problem that if it's...
It gives you an illegal argument. Because
So the bean doesn't say that, look, if one type is a super type of the other type, is similar property?
Because it wanted a serializable, and the only thing we could promise that we were giving it was an object.
Yeah, but okay. Then I have changed it after I tested it, I guess, maybe. Okay, because I didn't see that problem, and only when you mentioned that I saw the problem. Here's the more interesting one, and this is what Derek knows more about this than he needs to. But what is my call going to be like?
It has a method that is often null, and it has an array of.
Okay, don't memorize. Just go ahead and try to think. I'm making a call. A call means
Method name, argument types, arguments.
an object also, maybe?
Yeah, target object.
And method name is enough for overloaded methods?
No, that's why you also have the array of parameter type names.
Which he loves. Okay, so you need some unique way of identifying the method. Okay, and fortunately in Java, we can just assume the use reflection capabilities to go and name that method. Okay, and again, I didn't know how general to be, and you can go berserk in these things. So what do you think this my type parameter here is? I got a long name. Do I need a comment? So what's an object ID?
These are like some of the most generic words.
It's something in the page.
No, object ID. What? Really?
An object, an ID, type. Is it the system identity hash code? So is it
Okay.
a normal-
Firstly, let's look at context here. What are we doing? Describing a.
Method call.
Okay. When you call a method, what all do you need to go and pass to the other end?
Parameters.
Okay. And
Object,
Method name.
no. What do you say? Hang on. So what did you say?
the object.
Okay. How do you go and identify the object? I can't give it a reference.
Yeah, I mean, you have to start with the class name, and then you would need some kind of distributed reference.
How do you guys go and name an object in RMI?
We give it a name when we register it, or we don't, and then it registers with class name.
But ultimately, what is the ID?
The name.
Name. It's some ID, right? That ID is in RMI, the ID is a string. Does it have to be a string?
Wait, in general or in general?
In general.
No,
So, what would object ID type be?
string.
Or anything. That's my generic parameter.
Okay,
Okay?
but it's always string, right?
So
Yeah, I'm pretty certain of this one.
what's it?
I said, but in Gypsy it's always a string, right?
Some aspects are, it's all customizable, right? So I made it such that the default implementation uses string. Okay? But I allow somebody else to create another version where it could be, say, int or something else. Okay? And maybe this was too much, but, I just.
Unless you put another buzzword on the paper for sure anyway.
Which paper?
Well, if you're going to write a paper about Gypsy,
No, you
I know
can't.
you just did it.
You can't. Trust me, you can't write papers on abstractions. Okay?
It lets you put extensible.
Sorry?
If you were to, let you put extensible on it everywhere.
Say it'll help with things in the cloud.
But
No, I was just, yeah.
the thing is,
Yeah, I know. I mean, those are some, but that will go to a buzzword conference. So,
the object ID type, how do you force that type to also be the type of the keys that you have in that global hash map?
Oh, you'll get a, because you'll get
So-
an error if you don't, you'll get an exception.
so
No,
there's,
that's it. It needs to be forced somehow. You need to.
yeah. So you can go and instantiate those things with different types. You can elaborate those things with different types. So I can have one registry that takes strings and the other registry that takes. In fact, I think my registry itself,
Is templated? Is generic?
maybe I don't remember, but it could be, right?
Yeah, that's it. That's what I was going to ask. Is the entire registry generic?
So what I did was I went very far with this generic idea, and then it gave me so many headaches and so many angle brackets that I said, you know what, I'm tired of it. So I looked at my notes, and apparently there's only one piece, one factory that depends on string. That's what my notes say, which is very good. Okay, but I can't promise you. I really got tired at some point of all the angle brackets.
It's a lot of code.
Yeah. So my serializable call. So there's a call and there's a serializable call. My serializable call extends with a string parameter. Okay, and I can have some other serializable call that doesn't take the string. Okay, and basically, so we did it in two parts. We went and had method and object for sure. Then how are we going to describe the object and args we've got here. The method we're going to describe using this. Okay, that's another serializable call. That's another type. And
I was going to say, that's the one that has parameter type.
yeah, and then this one is going to is got this parameter type names. Okay? So that that identifies them.
Oh, method is transient?
Yeah, that's why
it's always now, right?
No.
Unless-
It was always null because there was an off by one error in my bean serializer that ended up like not putting parameter type names in there. The problem came when parameter types is null. You get a null for the method that got generated inside Gypsy. The problem is that there was a catch exception E return null, so I couldn't actually ever see the exception. They got thrown.
Where
So I
was this?
assumed that it
Did
was
you
happening
write that?
quick.
Or was
No. It was like it was buried in Gypsy somewhere, and I couldn't tell where it was actually generating the error from.
Bad exception.
No, you go and you go.
You didn't even print up the stat.
Now it does. I didn't imagine people would have off by one problems in their serializers.
But it was only when you had an object array followed by a more specific array type. It was a really weird scenario.
We try to figure it
that came
out.
up because of I literally had a plus plus in the wrong place.
Yes, I don't know why I didn't put the exception there, and now it is there, you know. So in the one that I released, in fact, we went down. I said, really? I'm not giving you an exception there? So we went and tried to find the code where I do that, and it was not easy. We found the code, and I said, please go and tell me where the class is. I immediately went and put a print stack trace there, and it's there. Okay. So, okay. So this has to be transient, though, right? You guys get that?
Yeah,
I can't just pass up on the project. Okay.
But that was the thing that was confusing me. It was like, of course it's going to be null. Why would it not be?
Yeah, but then of course, if you had looked through the whole serializable structure and seen how did I debug with you, I would have said, let's look at everything, because I'd forgotten everything too. So what about type names?
I couldn't figure out where it was actually trying to regenerate the method.
And then we ran it through Gypsy serializer. We saw the type names were populated, so we figured that out. Didn't take us too long together.
Yeah, once I had someone who actually knew what was going on.
Okay, so what now we can see what a marshaller has to do. Marshaller gets a marshal call made on it. It said, please invoke this method on this object, on these args, on this object. And it goes and says, I'll return to you a serialized version of that call. Okay? And I say call rather than serializable call because this is where you can make it some other ID type also. So this is so marshaller is sort of, it's very concretely defined for you right now. Right?
So how does method get populated?
From the other data type, transient, right? So there's enough information there. There's the object. There is the object class name. Object class name was also there somewhere?
There was a target object, and from it you could get the class name if you wanted to.
Okay.
But yeah, the client side has access to all of this. Like this is before it gets serialized, so it's trained. Like even though the method's transient, there's still a method that you can get your information from.
Oh, okay.
So there's a method at the caller end.
Right.
There's a method at the callee end. From the method at the caller end, which is going to be not transient, the serializable call gets created.
Okay.
That will have a non-null method in it. But because it is transient, that object will be sent to the other end. The other end will go and say, give me the method. Whenever it says get method, my object says, has the method been initialized? If it has been, it gives it that method. Otherwise, it goes and takes the surrounding environment. It takes the object ID, figures out from that the class. From the class, it figures out the type names and the method, and it extracts the method object through reflection and passes that object.
You can also generate a method from scratch with all the
Yeah.
information. That was what.
Right. So the first time I'll generate that. Next time you do get method, it'll just return the method it had done.
Okay.
Okay. And somewhere along those lines, it has to do a class for name, which is where we are getting in trouble here. Okay. Okay. Synchronization. That is the aspect that you guys have to deal with for the next 1 week. Okay. And let's understand this. So remember, we generate call message for call using exported information. Now we're going to go and process the call message at my local end. And do you guys remember what the processing of call message meant? I've generated the serializable call. What should I do after that?
When I go serialize that call.
So I can go and send that. That's what this is saying. Communicate that call on the data port. So this one generated the call. This one communicated the port. And before that, I have to do some action. Actually, I have to do 2 actions. Think about it. What if my call has an object that is not serializable? What am I going to do with that object? I'm making a call, and in that call is some value that is not serializable.
Don't our serializers throw an error if it gets something that's not serialized?
No, but just imagine that the call, your serializers.
You told us to. So
Right. See, I haven't told you everything, so I'm trying to lead you to a question because Gypsy doesn't rely on that. Let's see. So I made a call.
So if it's not serializable, do you just pass it to one of your pattern serializers and hope for the best?
Remember, I'm trying to get to the remote part. What if it's a remote object? Then I have to go and generate a proxy for it also. Okay. Remember, when you guys say register and when you pass yourself, a proxy for you has to be sent. So things are not quite the way I described them earlier. We have to do something more than just send the object, the parameters in the form they were given to us. We don't.
Okay. So if the parameters are to a remote object, you have to sub in the proxy.
You have to do that. Okay, and maybe the marshaller is doing that, and maybe not in the process call. But we have to do some action like that, and I think that I'm assuming happens in this step. Okay, the marshaller does all of that stuff, and we'll actually look at that thing different. How do proxies get sent without having to generate proxies at the server end? That's what happens. But what else has to happen? And what was the keyword before? Synchronization. So can you see some synchronization step that has to happen here? If I'm a function call, somebody made a call, some thread made a call, I serialize that call into an object. What do I do with the caller?
Oh, you have to wait it. You have to tell it to wait until you've got a reply that you can.
That's a new verb, right, for computer science. Yeah, you have to make it block. Okay, that is the part that you guys have to deal with. And how are you going to make it block? You guys are just going to have a receive call. And if your receive works fine, you'll get the right value. Okay. And the receive value you will get now will be one of the messages that you guys. Will be one of these internal RPC messages and not.
When we're implementing receive, we can just send back in for now, but we have to deal with that once we implement.
Yeah. Right now, your receive is anything because you're just writing a program to show receive. Yeah.
Because the send doesn't wait for the reply.
Yeah, send's not waiting. Yeah. Okay. So this is the part that you have to do. And then when a message comes in, what is this processing going to do? Unblock. Okay. So you need a receive trapper, some work in the receive trapper. You need some work in the send trapper. The send trapper is going to go and, because the first thing I ask you guys to do is say, look, my procedure calls don't wait. You make your procedure calls wait, which means your procedure calls must do something different. And then I say, now that you know how to go and do wait, please replace my function waiting with your function, with your receive calls also. That's sort of the assignment. Okay? So these are the two things you have to do. And let me just tell you again some of the architecture here. So again, there are these trappers that you guys are getting into, which you didn't really need to get into. But
I don't remember needing a trapper.
no.
Yeah, we don't
Yeah, that was
have
a question I had.
Right.
Not for the receiver.
Okay. And again, I'm telling you all the details, but just to remind you guys that these trappers exist between ports. And how we went from the object to the byte buffer port, we put a couple of trappers there. This port does almost no work. The real work happens in these trappers here, one of which just forwards the object directly and the other one serializes the object. It is this trapper that went and called your serializer to go and send the object.
The forwarders are the trappers.
So the trapper can be either an adapter or a proxy. So I can have chains of trappers. Okay? Between any two ports, I can have either 0 or n trappers. Okay? So when you go and, by the way, the reason why you can't do subclassing of the overriding the notify method is because your trapper is the one that's notifying.
I know it's fine.
Right? And if you didn't set a trapper, you'd be the one responsible for notifying. Okay? So there are these trappers that do the work, and between the object port and the buffer port are a couple of trappers. One is just forwarding, which you can replace with your own object, and the other is a translator, which you can also replace with your own object. But in general, I provide these two placeholders, and you can replace them, and when if you want. Okay. And similarly, between the RPC port and the object port will be trappers, right? Along the same principles. Because RPC port uses the object port to communicate the serialized call. And where will the processing happen? In those trappers. Okay? And now these two trappers, do they have to have any shared state, the serializer trapper and the deserializer trapper?
Yeah.
What
Well,
shared?
they need to be using the same instance of the serializer because they're.
Do they?
Oh no, I guess they don't.
The same factory.
Yeah, same factory. So yeah, okay, yes, they have to have the same factory, but they don't have the same instance of the serializer.
So no data structures.
Okay.
Will the trappers in the RPC case need to share some state? If they are synchronizing?
No.
I wouldn't ask the question if the answer was no.
Well, so
What is going to happen at the send end? I'm going to make the thread that's making the function call do what?
has to wait. Let's move on.
In some data structure? And who's going to unblock it?
Itself. Oh no, so the other one. So it's going to make a remote. I guess it makes a remote call just for the.
It just sends a data. It just sends data.
Right.
And then the data arrive along the received channel.
Yeah. And the receive channel unblocks the send.
Okay? So you need some synchronizing data structures between these two trappers. Okay? That's a basic principle. I've told you guys pretty much what code to look at, and with this sort of high-level picture and that level of detail, you can do it all before Tuesday if you need to. Okay? All right. No, but you'll need that for the next part. Something similar.